Okay, I think we're live. Thank you so much for joining our live stream. I see that some people already joined in, so I think we can start. If anyone was attending our last stream, welcome back. If you're here for the first time, thank you so much for joining. My name is Anya. I'm a business development manager of Kmine, and if you haven't already, please follow our LinkedIn page where we post our announcement for our future streams. So today we're gonna talk about optimal cutoff grade. Let's go over our agenda. We're gonna review a brief history of the development of cutoff grade notion, and we'll talk about it using as an input or as an output and how it's done in Kmine as well. And in the end, we will talk about cutoff grade in terms of optimization, and we'll answer your questions. So for people that join our webinar for the very first time, I just want to highlight some of the aspects of Kmine and what we are all about. Basically, Kmine is a mining software company that has been on the market for almost 30 years, and we provide one standalone application. This application is customizable and adaptable for each company's needs, and that allows us to work with a company of any size and provide a reasonable pricing because our solution is model based. And Kmine also offers a user-friendly interface and functionality that covers all stages of mining cycle, including short-term and long-term planning. So what does it mean specifically? Today we build 12 models for open pit and underground mine. Each of these models was created based on actual real use case of a company that we worked with, and each of these models keep expanding its additional features, calculation methods, tools. Our engineers not only set up the whole company's infrastructure during the implementation of our solution, but also assist our client at any stage of work, creating 3D models, planning schedules, estimating resources and reserves. Each of these 12 models that you see on the screen can be used as a standalone model and used in conjunction with each other. So each company can pick its own set of models covering its own specific workflow. And that means that also different departments of a company can exchange information within one space without any obligations to create SharePoints, fight compatibility issues, or waste of time on import and export process, or adjustments of the data. We also offer customized solutions that we integrate upon the request. We actually added new solutions recently, precisely two new ones. First, it's end-to-end planning. What it does, it allows you to automate the planning of all the stages of production process until the moment the product is loaded, and you can have it split per shift per day and plan even the load distribution on the equipment and many other parts of the process. The other new solution that we are releasing is an IoT platform that will work on web-based interface. This is the way a game changer for top management of the company and its divisions, because the solution transmits real-time information from IoT devices and personnel, displaying things like gas consumption information, tracking location of equipment and personnel, creating dashboard based on this information. And these analytics are also complemented by historical data, so the company can receive heat maps about where employees have the most frequent problems, when equipment needs maintenance, and other criteria. And all this information will help managers to get real-time information and solve problems efficiently and on time. The other custom integrations that we provide is open pit and underground dispatch integrations. What they do is basically they obtain and visualize information from dispatch systems for various services and helps engineers to operate the open pit and underground mining efficiently. Also, in Kmine, you can import data directly from surveying equipment. Actually, this is one of the areas that we improve on a daily basis. Let's just switch the slides. Here we go. So yeah, so basically our goal is to create the most simple and automated way to gather data from the deposit. And people would not have to deal with papers or Excel. And in one of our solutions that we integrated different dispatch and fleet management systems like Wenco, Mindstar, ACK Modular, and others. And you can basically import data from drones and directly from other surveying equipment. We also offer different customized integrations all the time, whether it's ERP system or really any other external information system that would allow us to receive information and import it to our application, which basically allows our customers to manage all the mining processes inside of one interface. Besides software and its development, we also offer different types of services, since we have a lot of mining engineers, geologists, planners, surveyors, and other professionals in our staff. So while we were developing our solution, we also worked in our services on parallel. One of the best ways to actually enhance the product is when you do the consulting work, because that's when you face challenges of the product. That's when you know exactly what you need to add, what kind of tools in order to speed up your work and improve the results. And that's why most of our functionality was based on the real case, real use cases, and real project instead of just theoretical knowledge. Today, our software allows to evaluate projects, create digital twins, create life of man plans, calculate resources, and other processes. Okay, so what is cut-off grade in general terms? Uh, Basically, it's a limit indicator of the mineral's content that divides the mineral into an ore and overburden or waste. In general, there are a lot of methods to determine the cut-off grade, and each of them has its own pros and cons, but overall, by determining the cut-off grade, you can achieve a certain objective in economic benefits of resource utilization. So if we keep dividing this objective, you can get more specific goals like immediate profits, present value, or maximization of total profits. But what's important to understand is that we need to recognize that we do not simply calculate cut-off grade to get a definite answer. It's a strategic variable that has major implications on my design. And in fact, cut-off grade always changes as the economic environment changes when it comes to metal prices and mining costs. And the profitability gets affected not only by metal value, but also by presence of unwanted material in an ore block, because it increases the processing cost. Talking about the history of cut-off grade notion, we decided to highlight a few moments that played a major roles in the development of the concept. And I'm sure some of you would like to add a few researches in between, so feel free to comment. But from our perspective, there are 4 important milestones in the cut-off grade development, which started in Mortimer in 50s and ended in 2014 with Rendu. Of course, the researches keep happening and notions keep developing. So who knows if we can add another important milestone in the coming years. But that's what we come up with so far. So Mortimer was the one who pointed out that material is classified as ore if he meets the 2 criteria. First, the average grade in it should bring the mining company a certain minimum income per ton of processed ore, and that includes standard profit. And also, the lowest grade material also should pay for itself. So if these 2 criteria are followed, then a mining company achieves a bare minimum, meaning it receives profit, and the samples contain grade that pays for its mining and processing. That's being said, when analyzing and planning, these 2 parameters should be justified: limited cut-off grade and minimum average grade in the mining block of the enrichment plant's ore flow. And so if we follow Mortimer evaluation, there are 2 parameters of the cut-off grade, and we base our planning on the highest one. Each of these parameters has its own goals, meaning, and associated costs. Unfortunately, Mortimer did not detail the list of costs that should be taken into account when we calculate these parameters, but like break-even cutoff grades, none of Mortimer cutoff grades take into account productivity of mining, enrichment, and marketing processes at different stage of mine operation, and other important mining parameters like ore extraction sequence, opportunity costs, and other costs. So that's why they really cannot guarantee the maximization of any mining project values. So that's why this method should be verified by economists before practical use. But here's the sequence of calculations according to Mortimer. Here we have which is required average grade of ore flow at the enrichment plant. And we have AW, which is the grade in the admixture that replaces ore losses. So the calculation begins with the block model for a block, ledge, or deposit as a whole to construct a function of dependence of the average grade on cutoff grade and fit the regression line to it. Also, the decision on the cutoff grade can be made according to the tonnage grade chart. But then we need to calculate the required average grade of ore flow according to the first formula. After that, we should set the ore loss, or whether it's actual or planned, it has to be in fractions of a unit, and determine a W grade in the admixture, which replaces the loss of ore. Now we need to determine the average grade of the ore flow at the enrichment plant according to the formula number 4. And then equating the obtained grade to the required one, we obtain the value of ACMI according to the formula number 5. And finally, the cutoff grade is calculated from the regression equation or according to the chart tonnage grade, as you see, point number 6. So both Mortimer's definitions, definition grades are determined by break-even calculations, but with different costs included. The required profit margin is treated as a cost for this purpose, and the corporate goal is explicitly stated to achieve a minimum level of profitability while ensuring that no material treated generates a loss. Compare this with implicit every tons pay for itself goal of a simple break-even cutoff. And the second component of Mortimer definition is focused on cost and product price and generates a simple break-even cutoff. However, neither of the Mortimer definition cutoff accounts for capacity of various stages of the mining and processing plant. And yet the geology of the deposit using the grade distribution relationship is now accounted for to ensure that some specified minimum level of profitability is achieved by the operations, making this what we might call like 2D process. I mean, it's significant improvement on the simple 1D break-even cutoffs, but not in a way that guarantees the maximization of any measured value. So moving on to the next milestone of cutoff grade development, the mathematician Lane is recognized as one of the classics of the science of cutoff grades. In '88, he released his work, Economic Definition of Ore, where he developed and published a fundamentally new theory of cutoff grades. And Lane's book was and remains the benchmark for mathematically describing cutoff grade solution using the maximum net present value criterion. In addition to the financial and geological parameters that are used in the break-even analysis and Mortimer's assessment, Lane takes into account in his theory the third component of the mining process, which is the ability of the production system to control the flows of 3 types of materials, namely rock mass, ore, and product. So Lane developed the basic principles of his theory of onboard grade optimization, which is based on the assessment of the cost of the project for shareholders. Basically, cutoff grade is considered here solely from the point of view of the mine owner, and explicitly sets goals of maximizing NPV of reserves, which does not guarantee a positive maximum NPV in all cases. But his methodology defines 6 potential cutoff grades. 3 of them are marginal grades and are calculated using break-even formulas. And these formulas taking into account that each individual stage of the production process limits the overall productivity. So, according to Lane's work, the concept of marginal cutoff grade is different from the classical limited cutoff grade, and in the first stage of cutoff grade optimization, there should be calculated 3 values of marginal cutoff for the stages I just mentioned. It's mining of rock mass, processing of ore, and obtaining the final product. Marginal cutoff grade is calculated using break-even formulas, keeping in mind that each of the stages are determined for the entire production process. And also, Lane considers that there are costs that should be taken into account when calculating marginal cutoff grades. These costs include operational costs, which are variables that are calculated per unit of output. There are also constant costs that are calculated per unit of time, one-time costs that do not depend on time on products, they're just there, and capital costs, which are design costs. Now, also, there are costs that are directed to maintain the production process. Overall, a rationally acting economic subject will first involve in the production the most suitable and therefore the most efficient resources, and only after their depletion, less suitable ones. In this context, opportunity costs are not expenses in the accounting sense. They are just an economic construct that can be used to account for lost alternatives. Opportunity costs might be taken into account when you make life-changing business decisions. For example, if you need to start a business or not, if you should continue to do the business or get rid of it. But in terms of the production, opportunity cost is the main driving force behind producers to maximize their profits. It arises when you need to consider alternative options to provide raw materials for technological stage with limited productivity. And Lane was the first one to demonstrate the importance of opportunity costs when you estimate cutoff grade. Some researchers of cutoff grade actually believe that opportunity costs should be taken into account only in the case when there is a performance limitations for at least one of the technological stages. And if that's not the case, then opportunity costs should not be considered at all. But that's not what Lane thought. And each of the 3 stages of mining, which are mining itself, processing, and marketing, has its own break-even marginal cutoff grade. And but they are also are intermediate values. With these values, full capacities can be only used in pairs, and they are called balanced cutoff grade. The pit has the maximum capacity to extract and move the mine rock mass to its destination. The capacity is determined by the size of its truck fleet, the number of excavators and drilling rigs, and it expressed as M units annually. In the same way, the enrichment plant has the maximum capacity to process ore, which is expressed as H units per year. Therefore, these 2 components are in balance when the amount of ore supplied for processing is in ratio of ore by rock mass, which equals H by M. Balanced cutoff grades are dynamic parameters that depend on things like distribution of mineralized material grades, and they are available for production at any time. But the role of the cutoff grade as a balancing tool is usually, even though it's understood, people really don't use it very often, and that's because cutoff grade is regarded as strategic parameter, and like a lot of managers refuse to use it for tactical purposes. So The search of the optimum cutoff grade led to derivation of 6 cutoff grade values from variety of potential options, 3 economically limited cutoff grade and 3 balanced cutoff grades that correspond to 3 possible groups of limiting components of the mining system. But only one of the 6 cutoff grades can be used in mine planning for a given set of operating conditions. Other pairs of mining production stages are also considered in a similar way. From 3 cutoff grade obtained in this way, the average value also should be selected. And to determine the optimal cutoff grade, we do not really need build curves, although they are very clear and mathematically justified by Lane. But it is enough to rank 3 cutoff grade values for each 2 stages of the mining process and choose average values. So the result set of cutoff grade values is called the optimal cutoff grade policy for the reviewed period. And the problem is to find the trajectory of the strategy that would lead to a maximized NPV. If we want to implement an integrated approach to find the optimal cutoff grade for the entire life of mine, then we need to perform annual forecast of economic parameters like prices and costs, and then we need to estimate mineral resources. But the cutoff grade policy optimization process uses a predetermined sequence of mining steps for each of which the cutoff grade is optimized. So NPV values should be recalculated each time during this process rather than using previously determined values. The parameters like forecasted economic conditions like prices and cost are used to determine the NPV, and then they are carried forward to estimate the cost, which is V, which also would be if we delay work by a year. So resulting 2V values are used to estimate the rate of change of NPV over time and hence the opportunity cost. The optimal cutoff grade for the first iteration is then being calculated, and that can potentially change the duration of any or all the production steps, and therefore the remaining NPV for each step. So, according to Lane's theory, the limiting factor dictates the terms. So we have to define the bottlenecks of each of the process, and based on this knowledge, make a decision. If we need more than plant can take, or do we need to get more than market can take, and based on that we can correlate the cutoff grade and also maximize the NPV. Ideally, we should work through each specific and possible option, and perhaps we could expand the capacity of the plant with some capital investment, but we also need to think about how this affect the NPV and the income for this period. And to answer questions of strategic nature, we need to use an integrated approach that takes into account the maximum number of variables and constant indicators to create economic models, and based on their results, depending on what goal we pursue, we need to make a decision. That's being said, despite of that the Lane's theory is recognized worldwide, it's not really popular and it's not really used in mining enterprises. And the reasons for that is that it's a lot of complex formulas that are understandable only to mathematics, which is Lane, and also somewhat difficult to represent in mining definition, the opportunity cost, and some extent balanced cutoff grade. But the whole emphasis is on maximizing the NPV of the whole project, and although it depends on the ratio of prices and cost, the discount rate, which often changes and requires regular recalculation of this parameter, so we can constantly be in this optimal territory. So moving on to the next milestone in cutoff grade development, we should talk about Hall, who thinks that cutoff grade is the least understood criterion for the profitability of the mining process, and determining its value is an integral part of optimizing the production strategy. So it cannot be an input, but it should be the end result of the strategic planning and optimization process. And Hall considers the development of the cut-off grade theory in time as a gradual addition of dimension to its definition. He considered in detail the increasingly complex models for determining and optimizing the cut-off grade, which eventually combined with the full optimization of the mining company strategy. And when it comes to Hall, he paid attention to specific aspects of work related to strategy optimization. First, it's the input parameters that are necessary to evaluate the full optimization strategy. Also, attention is focused on methods for selecting the appropriate grade identifier. For example, the value that is assigned to each block of rock to describe its value relative to other blocks, like in actual metal grades, metal equivalents, or money equivalents. And the other important aspect is the creation of the project performance criteria. So we can say definitely that, okay, strategy A is better than strategy B. These criteria are net present value, which is NPV, real option value, and as well as alternative methods for determining some of the cost indicators. But since conditions are all different, we need to apply specific optimization methods so we can achieve complex corporate goals. And overall, Hall's books provide some intellectual tools that mining engineer can use to turn the promises that their bosses have into reality. We all know how sometimes what board wants that does not translate into the actions of actual technical stuff to plan and optimize mine operations. And when you incorrectly calculate cut-off grade, it results in mines producing and processing vast amount of material that adds no value to the operation or to its owners. But basically, Hall devoted most of his monograph to a very detailed description of practical nuances and various real situations that can help specialists in developing the optimal strategy for the mining company. And overall, his work is somewhat a worthy successor of Ken Lenz's work of the economic definition of ore, but it goes far beyond Lenz's mathematics and explains how mining is planned and optimized using latest tools and techniques. But the last guy that we are going to talk about is Jean-Michel Rendu. Basically, in his works, he used the maximum NPV as a criterion for optimizing the cut-off grades. To optimize the cut-off grade, he proposes to use mainly an iterative method. So first, a cash flow or NPV is calculated based on the pre-accepted cut-off grade without taking into account opportunity costs. Then the opportunity cost and the amount of cash flow are used to recalculate the cut-off grade. However, the resulting a new cut-off grade entails the creation of new mining plans, new cash flow values, and as a consequence, new opportunity costs, which are used for the next re-evaluation of the cut-off grade. Basically, this process should be repeated until the cut-off grade and cash flow are stable, and it's very lengthy process. But here are some Rendu's formulas. First of all, we calculate the cut-off grade between the overburden rock and the ore according to the formula of on the paragraph 1, but without taking into account the overburden. Then we calculate the cut-off grade in the mine using formula 2. Then they account for the limitation of mining and processing capacity by calculating the opportunity cost and cut-off grade between ore and overburden. And finally, we calculate the boundary value of net smelter return. So the theory of calculation and application of cut-off grade according to Rendu is similar to Lenz's theory, since the main focus is on maximizing the NPV parameter, but also there are differences both in methodology and the application of cost types. Cut-off grade calculations take into account not only changes in NPV and cash flows in the form of direct cost and opportunity costs, but also other types of impact, including environmental or socioeconomics or ethical, political factors. And in conclusion to this theory, we can say that the main goal pursued by Rendu was to maximize the NPV, which is attractive to investors and company owners, but the difficulty lies in the need of many iterations. So this slide represents traditional cutoff grade search formulas. And after we got review of the history of the development of the whole notion, what do you think? How applicable are these formulas? I mean, you can comment below, and we can discuss it in the end. But of course, I mean, these formulas can serve as a guideline in order to carry out basic calculations. But applying the results of calculating simple formulas can lead into incorrect definition of a strategic indicator. So this result may be reflected in an increase of unrealized potential of a company, or in inflated cost for production of finished products. So cutoff grade is not a simple indicator. And so far, we have become familiar with the methods of calculating the cutoff grade from various points of view according to the opinions of different experts. And we can review the most significant factors that are affected by cutoff grade. The most significant is amount of minerals. Also, depending on the choice of cutoff grade level, the quality of the processed material changes significantly. Of course, the level of cutoff grade will directly affect the amount of rock mass removed from the pit and its quality. And as a result, the scale of the mining enterprise depends on the choice of cutoff grade. Also, drastic changes in the cutoff grade itself can affect the cost of mining. And in most cases, the mining of a mineral is done by a specific method, which also can be affected by the cutoff grade. Also the choice of cutoff grade affects capital cost, operational costs, and is based on the impact on the scale of the mining. The greater the productivity of the pit, the more productive the equipment should be. The less productive equipment is required. And again, due to the impact on the scale and life of mine and other factors, all of these factors will not remain unaffected. They all gonna change. So if we kind of like slightly expand our view on the influence of cutoff grade, we can see that it also affects the physical aspects of a mine. For example, the size of pit, dumps, warehouses, even factories. And it also affects the price of the final product, cash flows, and other economic indicators. Now, let's remember that the main thing that we discussed today is the cutoff grade cannot be constant, right? Like it must be flexible, adaptable to conditions, which means that all of these factors on this and previous slides affect the value of the cutoff grade indicator itself. So ideally, we get feedback once we review the results of the project, when we see the whole picture. And roughly speaking, when we analyze the financial model that involves mining operations, the cutoff grade should be considered as a variable indicator, and the one that provides the necessary specific requirements should be selected. Most often this is maximization of the NPV. And this slide presents the consequences of or results of using an over and under cutoff grade. As I said earlier, the main thing that is affected by the value of cutoff grade is the amount of the rock of interest in the mine. So from this life of mine and other derivatives up to the disposition of state authorities in the plans for development of a particular deposit, all of these things would be affected. So when we start developing a new deposit, right, the main task for mining engineers is to determine the place where to start the development. What's difficult is to find the place that actually should correspond to the best quality and the largest volume with the lowest stripping ratio. Of course, there are many more factors to consider. The main thing is to get as much profit as possible, and then during the first stages of mine development, and that would increase the NPV and return investments. So the optimal contour of the deposit should be determined, and for this, it's necessary to accept the cutoff grade for optimal contour. So, but there is one more question: what should we do with the dilution, and like when we considering the cutoff grade? If we pursuing the goal of maintaining and increasing the company's profits and not losing the potential of enrichment, then the cutoff grade should be increased by the percentage of dilution. The volume of export of minerals should be increased by losses, and dilution should be taken into account. But what mining engineers should do with lower quality minerals? So if we take into consideration that maximization of the NPV is achieved under conditions that all links in the production chain are fully loaded with a maximum quality, there is often a surplus with lower quality, and in this event, there is a spare capacity at the factory, and most likely that means that we can use a mineral with a lower grade, and vice versa. If there is no reserve, then the cutoff grade must be increased in order to increase the profitability of the final product. But what generally happens is low quality materials are stored in temporary warehouse until better times. These warehouses can be either active, like replenished or depleted over time, or cumulative. Storage warehouses usually in this zone of expecting changes in the production of technology or in the market for raw materials. All associated costs should be included in the calculation of the choice of warehousing strategy as well. So it can be re-excavation, bulldozer work, additional transportation, royalty, and other costs that usually associated with maintenance of warehouses. But in the event of an increase in prices for the final product, the cutoff grade can and should be revised. So as well as the strategy of removal rocks from the pits, storage, etc. So how we choose the first cutoff grade, right? So if we go back to Lane's method, we will see that despite its complexity, it actually allows, in some cases, to naturally abandon the blind following of prices and work profitability in the situation when economic parameters change. It would be more appropriate in such a setting to adopt one of the balanced cutoff grade values. So where possible and justified, in medium and short-term planning, we should use this method, especially in pits that develop single metal deposits. But at the same time, we should not forget that when cutoff grade was calculated using this method, there are temporary deviations from cutoff grade policy in the long term, so it's necessary to return to it after the situation stabilizes. In most cases, where it's impossible to use Lane theory in medium and short-term planning, the Mortimer method remains the way out, which provides kind of like this comfortable life for a company and even some income for shareholders. But in critical situations, when we need specific required amount of conditioned ore with the necessary properties, and it's not available in the pit, and let's say the enrichment plan is idle, and the last resort should be applied, which is the break-even cutoff grade, which is usually associated with high risk of not meeting corporate goals. But all company policy during this period should be to bring the mine back to the point where it can be developed at cutoff grade specified value, and it can be done in life of mine plan. So calculations of cutoff grade values at the stages of production are usually performed by iterative method. It also can be done with the help of optimization software using the maximum NPV criterion during the entire life of mine. The cutoff grade values obtained here should be taken as a guide for all stages of mine planning. Only small temporary deviations from this guide are allowed, with a mandatory return to it as situation stabilizes. But of course, critical situations are also possible, but they kind of like should not be a rule. As you can see from a diagram, all strategically important variables should take part in the process of optimizing the cutoff grade indicator. Now, the opportunity cost is the cost that happened in order to replace or delay the processing of 1 ton of ore that should be scheduled for enrichment. And it happens when rocks that are not planned for extraction and processing get into the way of mining process. If there are no restrictions on extraction, processing, or marketing, it does not affect the expected cash flow, and there are, let's say, no opportunity cost. Then in this case, this allows the use of material with a high grade of useful component in the production cycle. But replacing or let's say delaying the processing of a ton of ore scheduled for processing means that the associated revenue will not be generated as expected or as planned. We can try to improve one of the participants in this whole technological chain. And for that, we should use the following sequence. Initially, it's necessary to answer the main question, right? Will this improvement be profitable? We calculate economic indicators with the participation of improved participants in the production chain. Then, for example, we got a positive result, which is higher than the previous one before the improvement. Then we need to take the capital cost into account, and we should see over what period will investment be returned. And if the period is acceptable, then we can continue our evaluation. Finally, you need to include all the variables in the economic model for obtaining the final product and see how the main indicators changed. And the indicators for evaluation can be the life of mine, total capex in the period, total opex, payback period, margin, income, NPV, and many other indicators. So all of these indicators must be evaluated in the long term, not only in the time when they enter into calculation. So now that we already familiarize ourselves with the concept of cutoff grade, let's answer what is cutoff grade in terms of optimization, right? We already found out that what will happen to the deposit if we do not follow the trend of cutoff grade optimization. What will happen is potential loss of useful component or extensive cost for the enrichment of raw materials that do not belong in the factory. And it follows from this that the cutoff grade is not input information for the optimization process, but it also not an output. It is something with which there is a lot of work to be done and to play with, change values, evaluate results, improve, optimize. No one can be sure that the optimal cutoff grade obtained as a result of an integrated approach, and its determination will be the same for similar conditions. So in each case, it's individual. So you can't just take one of the proposed options and blindly use it, because in this case we can't talk about optimization or NPV or any other economic indicators. So in this case, what we can define as cutoff grade today is not an output, not an input. It's a parameter that has a huge influence on a lot of very important mining, processing, marketing aspects, and as influenced as it is dependent on them at the same time. It should be flexible to adapt to various conditions. It should be updated. It's clear now that we have to make decisions at the right time, and it should be considerable because the influence of cutoff grade decisions are always mean the changes in strategic stage of the mine planning process, which basically influence the whole life of mine. Now, moving on to Kmine and how our software solves cutoff grade tasks. Let's take a look at the initial data that we would use to build a scenario for searching the optimal contours in Kmine environment. So here are the pits resulting angles. For rocks is 44 degrees. For soft rocks is 32 degrees. The price for final product is $90 per ton. So the cutoff grade can be from 10 to 20%, and we apply this to the indicator of magnetite iron. The cost of mining is different for soft and hard rock, and also depends on the elevation, but on average is $4.5 per ton. Losses and dilutions are 2% each, and discount rate is 10%. And annual productivity by mineral is 5 million tons. The cost of enrichment is determined by the dependency formula on the quality of ore, and also using this formula would determine the yield of the final product during processing. Now we can see how it's possible to use Kmine for indicators analysis. On the side note, it's all artificial data. It's not like a real data or real deposit. So to evaluate cutoff grade, we should perform several scenarios with only one different indicators, which is cutoff grade. This way we can compare the data. On the left part of the plugin window, you can see that there were processed 11 scenarios in which the cutoff grade varies from 10 to 20%. All other indicators are unchanged. So to demonstrate the calculation results, let's just compare two of them first, the largest and the smallest cutoff grade. And as you can see, the difference is really significant. Preliminary, we can conclude that the optimal cutoff grade is in this range. Now, taking into account the fact that in this block model, there are several ore bodies, and one of them has significantly lower grade of magnetite iron, we can observe a significant difference between the optimal contours in the western wall area. Based on this, we can conclude that almost all of the difference in indicators can be concentrated in this place. So each of the created scenarios represent a certain cutoff grade indicators. We can preliminarily determine its influence on the results of calculating the optimal contours and economic indicators already in Kmine directly in plugin. So by going to the diagram tab, you can see the value of the main indicators of the plan in two modes, accumulative and differential. The graph shows the export volume of rock mass and profit. And based on this data, it's possible to perform preliminary analysis of the obtained results. Once the ore growth ends and the overburden continues to grow, this is the first sign that subsequent price adjustment factors are not of interest because they are not profitable. So, and also pay attention to the line that displays the profit. The resulting surface can be also uploaded as wireframes, whether we consider them separately or together. They can be used as a separate type of analysis of the results, and it will give an understanding in some aspects, such as what part of the pit is worked out and what is not and why. And as you can see, the significant difference are concentrated on the western side of the pit. And in this way, the geometric difference in several contours can be seen and evaluated. Based on the number of discarded ore according to the cutoff grade, we can conclude that predominant content of magnetic iron is in ore body. As an option, stop at cutoff grade, which will be the limit of the jump in volumes. And of course, it's worth making sure that actually the plant can handle such quality. So, I mean, for a more in-depth analysis of services, it's better to review them in different sections from different angles. Some details only can be discovered with the detailed approach, but it's kind of like a question for another session. And finally, as we approaching the end of our presentation, we can review several ways to analyze the resulting information in tabular form. Basically, the results in tables can be easily exported to Excel and other formats, and you can analyze further, get creative. It really depends on what you want to get in the end. But let's consider the general option, right? In the first comparison, the information was provided to compare 11 options, and each of them was presented in two interpretations: price adjustment factor of 1 and optimal 1 in terms of NPV. The optimal one, as a rule, has a slightly lower volume of rock mass removal, so you can notice some unevenness in the distribution of rocks, especially in overburden. The main trend is still being followed, which is the higher the cutoff grade, the less ore is sent for processing, the lower the total NPV and the total profit. The stripping ratio descent grows, and the service of life of mine also decreases. And when you review calculation results in specific software and compare data on identical price adjustment coefficients, you can actually determine the magnitude of influence of this indicator on the final result. In other words, let's check the sensitivity of the main indicators that depend on the cutoff grade indicator. As you can see, the graph has a very clear and direct trend, but the degree of influence can be assessed in terms of indicators. So the amount of ore varies from 55.5 to 20.4 million tons, overburden from 150 to 84 million tons, and profit from almost $700 to $307 million, and NPV from 392 to 223 million. Well, what is, and this is important, the life of mine varies from 11 to 4 years. This is the proof that these indicators is the most important for detailed analysis and requires constant and close attention. And what would happen in case of incorrect choice of cutoff grades is we already considered today, and this is kind of like a good example. And finally, we can evaluate the results in terms of maximizing the NPV, and these are the most interesting ones. So what we can see. So it's not rational to use cutoff grade up to 13%, since the volume of ore does not change, and ore, which is more difficult to enrich, will be supplied to the plant. The cutoff grade of 15% and above significantly reduce the life of mine, which is also highly undesirable because it means like the number of negative factors. The cutoff grade of region of 13% ensures profitability and high NPV, and ensures the maximum amount of ore to be processed and maximum life of mine. And it can be counterbalanced by 17% of cutoff grade, which will limit the amount of processed low quality ore, provide faster return on investment, but at the same time reduce the life of mine. So the choice should be always to combine with the goals of interest of the company. What does it want? It wants to reduce life of mine, but get fast results, quicker, and return of the investment, or it wants more longer life of mine, and it's fine with the balanced results. And it's also worth remembering then when it comes to cutoff grade optimization, all other indicators involved in the calculation are also taken as constant values. But in reality, they actually change all the time. Their dynamics are constant. With every ton of rock removed, their changes, and that's basically triggers a necessity of constant monitoring of the cutoff grade level under certain conditions. The decision to use the optimal cutoff grade should be basically made jointly, and at the same time, planners, manufacturers, management, everyone who's actually directly involved in the preparation and marketing of the final product should all have discussions, because overall this decision is strategic. All right, so let's have some questions here. I would like to include actually in this conversation our mining engineer Vitaly, who will answer your questions. Vitaly, do you hear me?
Yeah, hello, Anya.
Okay, hi. So the first question is how often actually the cutoff grade should be reviewed?
Okay, thanks, Anya. So, unfortunately, my English is not so good as yours, but I'll try to to give you an answer. So, okay, so first of all, we have to understand which exactly cutoff grade we mentioned. So, is it break-even cut-off grade, or it's one of those three different cut-off grades that we mentioned when we spoke about Lane's theory? So all through all of them change over the time, but some of them should be reviewed more frequently. So based on the experience, we have to decide the size of cut-off grade that we will use for optimization. It is necessary to understand what impact it has on the mine in general understanding. Um, the value of category could be underestimated or overestimated or taken into account just the average value. So, and the frequency of the revisions of the category will depend on this. It is necessary to constantly control the break-even cut-off rate and the one that gives the minimum required profit as per Mortimer's method. So profitability figures should not be less than required. So in today's presentation, we looked at the moment of influence and what cut-off grade depends on. So my point of view is following categories should be reviewed at least when there has been a significant change in the production cycle in any part of it. For example, in case of our productivity of the mine will increase, so it means that we are able to spend the more material for the processing plant. Or should we do that or not? Or we just have to increase our activities on the stripping areas and, for example, open some areas for the future times, some kind of perspective areas. So, or otherwise, we can increase our cut-off grade and it will reduce our pressure for the processing plant and will increase our profits as well. Because when we increase in cut-off grade, already we know we will reduce the quantity of material that will go to the processing plant. So this is just one example of many others because all of the indicators could change. All of them are changeable. So the most important thing is to react at the right time and in order not to lose the profits. So the main criterion is affecting the size of the pit during optimization is the cost of the final product. If it changes significantly, attention should be paid to the cut-off grade as well.
So, if we talk about like break-even cutoff grade, right? What are the disadvantages of it actually?
Um, Yeah, so as we will know, we can't just take and use break-even cut-off grade and be sure that all our production rates, all our economical indicators will be in a high level. So the main reason why it is unpredictable changes in prices, costs, and sometimes it in the characteristics of the ore that supplied for processing. All of it makes to be break-even cut-off grade highly variable. So besides periodic changes in market conditions determine reliable value for the break-even cut-off grade always give rise the following questions. So how to account for limited processing plant or marketing capacity, how to deal with variable recovery and processing rates, mm, its characteristics and changeable. How should losses and dilution and stripping ratio be included in the cut-off grades formulas? How to ensure the interest of the company, including the shareholders' returns in calculating of cut-off grades? So, and a lot of different questions. So, and finally, what costs should be included in the calculation to to the break-even cut-off grade? So it could be fixed, variable, capital cost, direct or indirect. So as you see, the answer to all of these questions are not so simple, but the economical well-being of the um, and sometimes the company's future depends on it. So Brian Hall has repeatedly said in his monograph that the break-even cut-off grade and break-even level should not be confused because there are very different things and it is completely up to the company's management to determine the right cut-off grade to serve the interest of the company. So the break-even cut-off grade should not blindly follow random fluctuations in the prices and costs and should only be defined as a reference parameter and used in critical situations.
And we have also another question. We mentioned about net smelter return. How is cut of grade related to that?
Could you repeat, please? Didn't hear.
Net smelter return.
Um, okay, just a second. I need some help with translation.
I think we talked. I mentioned it in one of the formulas that I believe Mortimer showed in net smelter return.
I think we can provide an answer a bit later for this uh, expert because I need some time to deal with it.
Okay. Well, no worries. I think we can also put it in the commenting, but as far as the question, I think that's it. And to answer with your questions, guys, yes, well, this presentation will be uploaded later on, and you will be able to see it and send it to whoever wants to check it out later on. Yeah, and actually, I see that net smelter return is one of the Randolph formulas. We're talking about calculate the boundary value of net smelter return. It's one of the Rendu's formulas that he used in the monograph. But I think that's it. Thank you so much for joining, and we will have another webinar before the end of the year. And don't forget to follow our LinkedIn page, and I hope to see you guys during our next live event. Thank you. Thank you, Vitaly.
Okay, thank you. Thank you, everyone.
Thank you. Bye.